All right, so this is a recording for the 4.3 homework. You're going to see two examples in there where you're going to need StatKey to be able to get your p-value. So let me share my screen. Which two problems am I referring to? These last two, 4.127 and also 4.129. So I'm not going to hit everything in here, but mainly I want to hit to make sure that you know how to get the p-value. So in here, again, you'll read over this, make sure that you understand the context of this. But what they are doing is checking to see whether there is let me get rid of that, whether there is an improvement for these treatments in average, and specifically whether it's higher for the treatment group. And so when you come down here, again, you'll do this for your homework. You'll write out the null hypothesis and the alternative. But for the alternative, since we are doing higher, or in other words, greater than, this is a one-tail. More specifically, this is a right-tailed test. Again, this is just to kind of give you some guidance when you're doing this. But try to do as much of it as you can independently. But if you get stuck, this is to help you out. So it's going to be a right tail test because we are checking to see if one of the averages is higher for one group versus the other. They also give you the statistics over in StatKey. So if you don't see them here, that's okay. They're going to be given to you where one group minus the other group, you'll be able to get your statistics. So you're using the randomization for differences in means, and this is the name of the data set, the DASS, depression reduction, healthy diet versus control. So whether the healthy diet is giving a larger improvement. So when you come here, you're going to go to your difference in means. You're going to come up here to select the data set you need. Let's see if I can find this guy. Here it is, the DASS, depression reduction, healthy diet versus control. And when you're here, you will see already that the two averages were here, the 7.865, the 0.763. But here's what you need for the statistic. They've already done the subtraction. So 7.1 is what you'll put here. And we want to see if this is enough of a contradiction to the null, which is going to be over here, suggesting that the two averages are the same. Now you're going to generate 1,000 samples, and then you're going to put your original sample statistic to get the p-value. So what that means is when you come here, generate your 1,000 samples. Again, here's the null in the middle, supposing that there's no difference. And since you only are needing the right tail, since we're doing greater than, you'll click that one. And you need to put the statistic here. This is the 7.1. When you click OK, there's your p-value. It comes out to be a p-value of 0.000, which that being so small means that it being less than, and I'll just put it here, it's, oh, my little mouse got stuck. This is your level of significance, and you want it to be less than 0.00, excuse me, 0.05. And it obviously is, since it's 0. And so then you'll be able to finish this problem out. The generic conclusion, you'll be able to reject. You'll be able to write a conclusion in context. It does seem, we do have evidence that the average for those with the healthy diet have a higher improvement with their depression. For this one here, it's now in regard to ADHD. It's now doing proportion for teens who have been diagnosed, whether it is higher for those who are more often or more frequently using social media. So again, you'll write your null hypothesis, you'll write your alternative. I'm not doing everything here. I want you to fill in those pieces. But you are doing, once again, whether it's greater for one of your groups. So another right tail test. Again, if they don't give you the statistic out here in the prompt, then it means that it's going to be over in StatKey. But this time we're doing difference in proportion. And here's the name of the data set and variables we need. So when you're here in StatKey, you're going to use this one instead, difference in proportions. And when you go to the data set you need, and where is this guy? Hopefully I didn't pass right by it. Oh, right here, ADHD, high social media versus low. And so over here, you'll see that they've already done the difference of, so here was for one group, high frequency minus low frequency proportion, and they've got 0.051. 0.051. This is the statistic that you're going to use to try to get your p-value, 0.051. And so again, here the center is assuming that there's no difference. Generate your 1,000 samples, and then either do the left, the two-tail, or the right tail, depending on what type of study we're doing. In this case, they're doing greater. So that's a right tail test. And so over here, it's all automatically going to give you some something to work with, but you need to change it to the difference in proportions, 0.051, 0.051. And again, this will always be slightly different. So yours might not be exactly what mine is giving here. But this is one where this is our p-value. We don't need to multiply it times 2 since we're just doing a right tail or a one tail. So we've got 0.008. At least that's what I got from my p-value. Yours might be a little bit different when you do it for yourself. But because this is less than the level of significance, 0.05, this does mean you have the ability to reject the null hypothesis, and also that you have evidence to support your alternative. In this case, you'll reject here, and then down here, you'll write your conclusion. Again, something to the effect of, it does seem like those who are more often or more high frequency users of social media do have a higher proportion diagnosed with ADHD as compared to those who are less frequently using social media. So I hope this helps you when you work through these. Again, make sure to do them, run through these procedures for yourself to see what p-value you get, but you're going to be still using the same statistics, the 7.1 and the 0.51. But let me know if you run into trouble. All right, take care.